The Earth is made mostly of rock. It's all around us, most everywhere we look. Yet, how much do we know about rock? Most of us know that there are different kinds of rock and that rocks are formed in different ways. But what about identifying rocks, actually telling one kind from another? It's not easy to know where to start, partly because there are so many kinds of rocks, but also because all rocks of one kind may not look exactly alike. There are some simple clues, though, that can help us identify them. For instance, this one's got streaks running through it. Streaks of different materials of which the rock is formed. There are various kinds of streaked patterns found in rocks that help us identify them. Some rocks have streaked patterns. What other patterns can we find? These rocks have speckled patterns. These rocks have, well, hardly any patterns at all. They're mostly solid colors. Solid-colored rocks, speckled rocks, streaked rocks. This is one way of grouping rocks, a way that helps us identify them. You may already have guessed that this rock is a kind of marble. Marble often has this sort of streaking. Streaks of this kind give us a clue as to how the rock might have formed. Perhaps over a long time, under great heat and pressure, the rock may have flowed, almost like a liquid. Streaked patterns give us useful information about rocks. The same goes for speckled patterns. A rock having this particular pattern is a conglomerate. Seeing the arrangement of its particles gives us a clue to how this rock might have formed. Perhaps separate pebbles of different sizes came together to form the larger rock. Can you think of where and how this might have happened? Rock patterns help us learn about the origin of rocks as well as their identity. What about identifying rocks that don't have much of a pattern? Obsidian is solid black. Obsidian is also quite smooth and glassy. This is another clue to identifying rocks. Texture. The texture of sandstone is much rougher than obsidian. Lava is rougher yet. Any idea how it might have gotten so rough? Does this give you a clue as to how the lava might have formed? Texture and pattern. These are clues to look for in identifying rocks. Often it's also helpful to know something else, the substances rocks are made of. This rock, for instance, is granite. Other rocks have a pattern and texture, something like granite, but they're not made of the same substances. Scientists identify the substances in granite as quartz, feldspar, and biotite. Such substances are known as minerals. Minerals are the building blocks of rocks. Rocks are mixtures of minerals. Sometimes we get a chance to see individual minerals all by themselves, apart from the rocks they form. There are over 2,000 different kinds of minerals, although only about 100 of them are commonly found. You can imagine the many possible mixtures of minerals there are in different kinds of rock. Some minerals are chemical elements, like gold. And sulfur. Other minerals are chemical compounds, like quartz, a compound of silicon and oxygen. Or gypsum, a compound of calcium, sulfur, oxygen, and hydrogen. Let's look at a collection of minerals and see what we can learn about them. Minerals can be identified with the help of a few simple tests. The color test, for instance. Sulfur is yellow. Rhodochrosite is pink. Malachite is green. Chalcanthite is blue, almost always. But in many cases, samples of the same material may vary in color. Specimens of hematite, for instance, may appear black or reddish-brown. A more uniform color is revealed with another test, a streak test. Every specimen of hematite, when rubbed against a hard, rough surface, leaves a reddish streak, no matter how brown or black the sample. Another test for recognizing minerals is the hardness test. With your fingernail, you can scratch the mineral talc. It isn't very hard. But to scratch calcite, you need something harder, like a penny. Apatite is harder yet. To scratch apatite, you need a knife blade. The mineral corundum is so hard, it can scratch a knife blade. Another test for minerals is to see how they bend or break. Mica is elastic. Sulfur is brittle. Fluorite, well, fluorite breaks in a very special way, along a flat surface. Breakage along a flat surface is known as cleavage. It's an indication of how the atoms in a mineral are arranged. The arrangement of atoms in fluorite leads to this sort of cleavage in 4 different directions. Calcite cleaves in 3 directions. Mica cleaves in just 1 direction. Cleavage is another test for identifying minerals. Some minerals look as though they've been cleaved, as this sample of hematite. But the mineral has formed this way, naturally. When minerals develop in such regular shapes, they're called crystals. The particular shape of each crystal is a further clue to identification. Here's a mineral that can be identified by its shape and by the way light passes through. It's transparent. The mineral is calcite. Notice that the image seen through it is double. We see 2 pennies, another characteristic of calcite. Notice how light bounces off this mineral. It has what's known as a resinous luster. helps us identify the mineral as sphalerite. Mica has a pearly luster. Luster is another clue to the identity of minerals. Another test has to do with magnetism. Some rare specimens of the mineral magnetite act as natural magnets, which is how the mineral gets its name. Minerals can also be identified with a test known as a specific gravity test. The idea of this method is to find the weight of a mineral first out of water. Then the mineral is weighed once again in water. The buoyancy of the water causes the mineral to lose weight. This loss of weight compared to the mineral's weight in air is a measure of the density of the mineral compared to the density of water. It's known as the specific gravity of a mineral. Specific gravity, magnetism, luster, crystal form, cleavage, hardness, streak, color. These are simple tests that help us identify minerals. Minerals, remember, are the building blocks of rocks. Seeing the minerals in this rock helped us identify it as granite. Rocks can be identified by the kinds of minerals they contain, by their textures, and by the patterns they form. Rocks and minerals, basic materials of the earth. You can learn a whole lot about them, starting with just a few simple clues to their identification.